All right, this is a lot of fun. This is basically the same thing we just did, right? We're going to use torque as RF sine theta, right? And we're going to use the fact that clockwise torques are positive and anti-clockwise. So ones that tend to twist that way are positive, and if they twist this way, anti-clockwise torques will make negative, okay? And we're going to torque about the left side of this beam right there. And so we've got the weight of this box, right? It's 12 meters long. So we're going to say that the weight of this box, which is 82 times 9.81, that's going to be acting at 6 meters. Since it's 12 meters long, the beam's weight acts at the center. So that's going to be at 6 meters. And then A is, how much is A? What's the mass of A? 25 kilograms. Right, and we're going to say that that acts 25 times 9.81 is at how far? 3 meters from the left side. And then B is, what is that? B is 15. So 15 times 9.81, that's the weight of it, right, is half a meter from the right side. So that's at 11.5, right? And then, and then we want to find how far this is. So this is 691 newtons, right? That angle is 72 degrees. And we want to find how far this is, right? Ooh, that's kind of cool. Okay, how far is that so that it balances out, right? All right, I think we're ready for this. So let's set up our torque expression, right? We've got positive 3 meters times 25, 9.81. That's this guy, right? Plus 6 meters times 82 times 9.81. Okay, then we've got, we're going to guess that this guy's somewhere in there, right? So we'll go negative x, I'll just call it x, right? Times 691 times the sine of 72. Okay? And then we've still got this last little torque there, plus 11.5 meters times 15. Now, my method here is that I just start at the left side at the torque point and I just move my way across. Things that tend to spin it clockwise, I put positive. Things that, this guy is anti-clockwise, that's why it's negative, right? So that's anti-clockwise. This tension here would tend to rotate the other way. You can't have a torque equilibrium without both anti-clockwise and clockwise torques. Okay, so, and then all of these downward ones would be clockwise ones. Okay, so we're just talking about which way they would twist. And now we're just solving for x. So basically, I'm just going to add up all these terms that aren't x. Divide by 691, divide by sine of 72. Okay, my batteries are low. So let's see, 3 times 25 times 9.81 plus 6 times 82 times 9.81 plus 11.5 times 15 times 9.81. I get all that stuff, right? Well, that's a big number. All right, and then I'm going to divide by 691. Divide by sine of 72. I get 11. It's 11.0388 meters. There you go. So just pick the torque point, right? I always pick the hinge, okay? Starting at that hinge, just figure out the distances. I think it's good to write down where they are, right? And then it's easy to just set up your expression. This one's clockwise. This guy's going to spin it clockwise. That one's anti-clockwise, right? The tension's going to tend to spin it this way, right? And then the weight here is clockwise. Okay? Yay.